Hi, everyone. My name is Hannah. Before I get started, just a few quick things about me. First of all, you can find me on the internet in case you want to contact me. My handle is usually @TechGirlWonder. That's my little logo. FYI, I do use she, her pronouns. I work for a company called Carbon 5. We are a product development agency. We work with all kinds of clients from small startups to big enterprises, and we help them turn their ideas into working software, whatever that looks like. We are hiring, and we're hireable. And there's a whole bunch of us right down there in case you want to chat with us afterwards. So yeah. Lastly, personal anecdote, that's my dog. She can vouch for me that I'm all right, so you know I'm an okay person. Cool. Just FYI, there's going to be no Q&A. Unfortunately, I do have about a full 40 minutes of content, but you can submit stuff to the app, and I will try to answer it afterwards. So yeah, this is a talk about reactive programming, and specifically why I think it's a great way to write front-end applications. It's in 5 parts, so here we go. Greetings to all of the legendary children, and welcome to the Functional Reactive Programming Ball. Tonight, the category is, what is a computer program? So a very important computer science textbook that I refer to frequently defines a computer program as a sequence of instructions for performing a task designed to solve specific problems. And I always tend to focus on the phrase sequence of instructions, because it makes me think about programs like they're a to-do list, right? Or if we were to look at a different context like a classroom, you might imagine a program as a lesson plan, a series of things you're going to do to get to your objectives. But are these really the right metaphors? So if you're writing command line tools, they might be. But if you are writing front-end programs, which is what this talk is about, there's maybe a better metaphor that I think of. And that's this, the unruly classroom. Because front-end programs are basically, they don't run sequentially at all. They're completely dependent on user input, and they're dependent on servers that you're talking to. And you're constantly getting interrupted when you do front-end programming. And that's really it, in my opinion. I think that interruptions effectively are the heart of front-end programming. So I'd like to talk briefly about a couple patterns we've used for dealing with interruptions in front-end programming over the course of UI development. So the first pattern, the very first one I ever interacted with, was something called the global event bus. And the global event, the first kind of programming I ever did was DOS game programming. This is C. You don't need to know C to understand what's going on here, hopefully. But what you would do in a DOS game is you could effectively override the BIOS of your computer, a very low-level kind of piece of software, and completely take over the keyboard or the mouse of your computer. And then you would write some code to take what was going on your computer, what was being typed into the keyboard, and maybe stored in a buffer or something. Oops, sorry. Got to get used to this presentation remote. Oops, sorry. You got the, No matter how much I practice, I always have a moment like that. That's okay. Anyway, so here would be like your keyboard handler, and then the rest of your program would essentially be a giant loop. You'd be looping effectively forever until a user did something like a quit. And then in the middle of that loop, you would read from whatever happened last on one of your pieces of hardware, and you would update the state of your program. The downside to this is if you wrote a bad interrupt handler, then you could effectively lock your computer, because once this is running, your keyboard doesn't get any input other than what your program does. So this would run forever. The next type of programming I did was in Windows, and Windows had a very small innovation on this, which is that they decided maybe it wasn't a good idea to give the average programmer access to the hardware, and so they took over the processing of hardware messages. Sorry. Okay. But if you look at the actual logic of the program, it's basically the same general deal. A loop where you process messages, dispatch them, and update state. And the main thing that you would write as a programmer for a Windows program is you would write a function that took each message, and you would take all the different messages, and you'd use them to update the state of your program. And it usually looked like a giant switch statement. And so that's the global event bus, and it brings us to about 1999, where we left the global event bus in the dust. Or did we? Because I don't know if any of y'all are doing front-end programming in React recently, but if you look at this and you look at a core logic function that's a giant switch statement where you take a message and you update state, this actually looks a lot like a Redux reducer. And Redux actually contains a lot of the global event bus pattern. So while programming in Redux, maybe programming like it's 1999, there are some good reasons why they went that way, which we'll get to in a second. But I want to talk about the next thing that we did, which is the main pattern and the main way we've been writing front-end applications for all of the years since then. And that's something called the observer pattern. So, but in order to explain this, because we're going to talk about the observer pattern a lot, I want to make a very short digression into the world of influencers. So let's say that you are a very important content creator, and you need people to see your content. How do you do this? So the old way, before the internet, you had to like track people down and be like, please watch my thing, right? And it was really terrible. But now we have such better ways, right? Because we have this new contract, which is like, I as the content creator am like, I'm going to make some content. And you, as my adoring fans, go on one of our wonderful, scary surveillance social media platforms, and you sign up and you subscribe to my content. And then when I make new content, you get a notification and you can watch it. And this is basically the observer pattern. In the observer pattern, you have a subject, something that essentially promises it's going to emit events, and an observer who subscribes to the events and then can handle them however it wants. That's all it is. And the fact is, and if you're doing JavaScript programming, even if you're not aware, you're probably using this every day. Here, let's look at a real example, which is, let's take the example of you've got two elements on the page. One is a toggle switch, and the other is an area that you want to change the text of when you click the toggle switch, right? So here you have a reference to the toggle switch that you've looked up from the DOM. And then here you have a function which will look up the other element and change its text. So how do you connect these two, right? Well, those of you guys who've done any JavaScript programming have probably done something like this. You subscribe to mouse clicks on the toggle switch, making the modify text function into an observer. You can now handle each mouse click by switching the toggle. So that's basically the observer pattern. So this is really great because it's a lot simpler. And at the same time, it's a much more localized scope. You only have to deal with the events that you care about, right? And so that's a much easier way to do programming. Now, there is a caveat here, which is you've got to set up the subscriptions. And as time goes on, you may find that setting up all the subscriptions becomes quite complicated. If you have ever tried to implement drag and drop in the browser, you probably, with just like mouse up, mouse down, and mouse over, you've probably found it's quite challenging. Because in the middle, you basically have to subscribe to the mouse being clicked, then add a mouse move handler, and then when you lift the mouse, you have to remove that handler, so you also need to be listening to mouse. It's just very complicated. Anyway, so the problem here is you're mixing concerns because you're both handling events and at the same time, you're setting up subscriptions. And I have this theory about how Redux got created, which is that the Redux authors were looking at, effectively, we're getting tired of the observer pattern, and they looked back and were like, let's try giving this global event bus another try. But all of this might be leading you to wonder if there is a better way. And that is the subject of my talk. So that way, in my opinion, is called functional reactive programming. And I'm going to show you how to use it to write front ends like a boss. So once upon a time, I was a teacher. I was really bad at teaching. I taught middle school. You should not learn from how I taught. However, this is about good teachers. And good teachers I don't know if you ever watched a good teacher teach, but they're kind of like Jedi. They have this way of like a student interrupts them and they like kind of like Obi-Wan the student back onto the path of the lesson, right? It's really amazing. So how do they do that? Well, so what good teachers do is, first of all, they have a lesson plan, but they don't use it as a plan. They use it as a guide. It's kind of a starting point. Because if you use it as a plan, you get interrupted very easily. Instead, you can think of teaching as essentially a series of planned responses to interruptions, right? And really good teachers know how to not just respond to interruptions, but to draw out lessons from them, to actually kind of like take the interruption and turn it and sort of magically fold it back into the key objectives of the lesson. And in a good classroom, it's almost like a series, no matter how it's interrupted, it's like a stream that just keeps flowing towards the end goal. So they really almost are like Jedi. By the way, I highly recommend, well, I don't know, I highly recommend, we ought to be paying teachers. My experience teaching is it's way, way harder than programming. I don't know, whatevs. So what if we program like this, right? Could we write programs as a series of planned reactions to interruptions? What would that look like? Well, so let's think about this statement, y equals x plus 3. You've probably written something like this in your programs at some point. So in a traditional imperative program, we know what this means. It means take the current value of x, add 3 to it, and assign it to the current value of y. It happens once, and then that assignment's done. But if you think about a different context, not a programming context, let's talk about the math context. In math, that statement actually represents an entire graph. It represents a line expressing a relationship between x and y. And in fact, reactive programming is similar. In a reactive program, y equals x plus 3 expresses a relationship between x and y, so that every time x is updated, y would also get updated. So you can imagine x as a stream of data values that over the course of time, right? And you just imagine new values are being emitted on that stream. So y, you can also imagine as another stream where each value is derived from the values of x. And you don't have to just think about numbers and data. You can think about user events. You can imagine a stream of mouse clicks over time, right? So that's the theoretical idea of reactive programming. But how can we write this into our computers that are really just executing sequences of instructions? What we need is some kind of a pattern. We need where each value that changes over time, and you could get notified that it's changing and respond. And if you think about that, that sounds pretty similar to something else that we've talked about, which is the observer pattern. And actually, we can use the observer pattern, but we're going to extend it a little and make it a little more, make it able to do a few more things. So let's introduce the observable. An observable is any value that changes over time that you can listen for changes on. So let's look at how this works. Okay. We have an x, and this x is an observable, and like in the observer pattern, we can subscribe to it. And we can subscribe, and here we're just printing out the values. So you can imagine if you wanted to print out the values of y, you could just subscribe to x and then print out those values plus 3. But what if we wanted to listen to y? So let's rewind a bit and think about x as a simple array. If this were an array of numbers, and we wanted to transform this array into the y array, Most languages have a construct for that. In most languages, it's called map, right? And this would take x, transform each value, and give us the y array. Well, with observables, it's actually it's the same thing. We have x as an observable of those same values, and then y is x mapped. The difference here, and this is a key difference, is that this is a mapping over time. So as x emits new values, and we're assuming that it's going to continue to emit new values for some time, each value gets transformed and becomes the current value of y. Let's look at a more real-world example. So this is, let's say we have 2 buttons and a ball, and we want to make a ball move between the 2 buttons. So we have a go left button and a go right button. And basically, we want the ball to move when we click the go left and the go right. So how do we do this with observables? Well, let's say that we made a stream of our left button clicks and our right button clicks. And so every time I click the go right button, it would emit on the right button click stream. And every time I click the left button, it would emit on the left button stream. So you can see that's pretty basic. So now, let's say we took each one of those click streams. We don't really care. There's no value associated with click, but we could transform the fact that it happened into a position, right? So we could take each click stream and turn it into a position stream. Now, if we take these 2 streams and we combine them, we actually get the current position of the ball. And now we are emitting the current position of the ball. Now, I'm using a library to do some of the animation, but that's basically, all there is to that. How this actually works in code, and for the rest of the talk, I'm going to be showing examples using a really great observable library called RxJS. Our remaining examples are going to be in JavaScript, but there are great Rx libraries in almost every language, and you can apply this to any language or any context. So the first step is, so here we're going to import various tools from RxJS, and the first step is to look up our DOM elements. Once we have the left button and right button, we can use a function called fromEvent that RxJS provides to convert this into an observable stream of clicks. Once we have those clicks, you can see that here we're just using map to map the fact that the click occurred to a position. Now, RxJS has a slightly different syntax where you put everything through this pipe function, but it's basically the same concept. Finally, we can merge those 2 streams with a function called merge that RxJS also provides, and this gives us our current position. We also add one more thing to this, which is an initial position for the ball. And that's basically it. OK, so you're excited. You've drank the Kool-Aid 20 minutes in, and I'm really excited it actually is 20 minutes in, like it says on the sheet. And now you want to use RxJS everywhere. How do you do this? OK, so first of all, I want to make a point, which is I was at a talk recently given by Laurie Voss, and he works for NPM, and they have like all of the datas on what packages are getting downloaded. So he had collected data about package downloads, and he was showing this graph about the React ecosystem and what's getting downloaded in the React ecosystem. And I saw it, and he didn't mention this, but I saw it, and I was like, wait, what is that? What is that line that's going way up? Is that, oh my God, it's RxJS, and it's more popular than React itself. So I talked to Laurie afterwards, and there's some good reasons for this. RxJS is being depended on directly by several very popular libraries. And you may not be using it yourself, but the lesson here is that the people who write the libraries that you depend on in JavaScript are using RxJS. OK, that's super cool, but let's say you personally want to use RxJS. To use Rx effectively in a real-world application, you have 2 things you need to figure out. One is, like, how do you actually architect real applications using RxJS? And second, how do I integrate RxJS with all the tools that I know and love? So let's look at a much more real-world example. This is probably something you've implemented at some point if you've been programming for a bit. A login form, right? And a login forms are pretty common. They kind of all need the same stuff. Your login form needs an entry for like credentials. It needs a way to submit it. You probably want to be able to display some feedback from the server if somebody submits an incorrect login. And you may also want to disable the submit button while the login is in progress, right? So you can see, not very exciting. You submit, you get an error, what else? How could we model this with RxJS? So let's start with 3 real observables. In this case, we have a username representing a stream of everything that the user types in to the username field, and a password field. This one's super secure because you can actually see what I'm typing. And then finally, we have a submit button, right? So from these 3 streams, we could actually come up with a stream of all of our attempts to log in, simply by taking, that would essentially what we need is it would need to emit whenever the submit button is clicked, and it would need to combine it with the last thing that the user typed into the username and password field. Once we have attempts, we could kick off a API request to a server, and that would give us a series of responses. Once we have both of those, we can derive a bunch of other stuff. We have login failures and we have login successes. We could filter those responses. And not only that, we could take the time in between when the attempt stream emits and the response stream emits, and we could convert it into essentially the state of whether our login is in progress. Finally, we could convert the successes and failures into some kind of useful data. In the case of a failure message extracted from the response from the server. And in the case of a success, we might want to get out a user token. And later on, we might take that token and get make a bunch of additional resources to get maybe some streams of data of protected resources that are specific to the user. And effectively, oops, sorry, did that work? You can see that effectively, this graph represents the entire state of our login program. And I'm going to go ahead and log in correctly now, because strange loop is awesome. And you can see that the passwords are submitting. You're getting, oh, did I probably changed the password to something I forgot. What? Oh, thank you. Yay, yay group. So the downside of making these interactive is you can type things wrong. Anyway, you can see that effectively we've gotten down at the very bottom that says my stuff. We can imagine that's a protected resource. Cool. How would you do this in actual code? It's actually not that complicated. So let's take this example, and here we have an API. This is just a simple, imagined API. It has 2 endpoints, a login, and a protected resource. And then here, let's say these are our 3 streams representing our 3 user inputs. Now, RxJS actually provides ways to construct these directly from the DOM. But in this case, I'm going to use something called a subject. Let's not get into what it is, because I'm going to show you a better way to connect these in just a second. But anyway, let's say we have these 3 primary streams, right? Once we have those, we can just use the combine latest, the with latest from operator that essentially takes every emission from the submit button and attaches the username and password to it. That gives us a stream of essentially an array of 3 elements. You can see that I'm sort of destructuring it in the call there, where you have, and I'm getting the username and password, and then using that to submit an API request. Now, the challenge with an API request is it returns a promise. And you don't really want a stream of promises. You want a stream of what the promise actually resolves to. So RxJS has an amazing operator called merge map. It's also called flat map in other languages, so don't get confused on that. And that operator can essentially be used to make the stream emit not the promises themselves, but what they resolve to. Once you've got that, the state of the login being in process can be derived essentially just by merging the attempts and the responses and converting each one to a true or false state. It's pretty easy to get the success, to separate login responses into success and failures, because there's just a filter operator in RxJS, and here we're just filtering on the status that's returned by the server. You can see the failure works the same way. And then once we've done that, we take the response from the server and we just use some maps to extract out an error message and generate that as a text string. We could do the same thing with the user token. And once we have that stream of user tokens, we can start this whole process over again and make another merge map call to an API. Oh, I see I have map there, not merge map. Oh, no, sorry. The last one is using a different operator called merge all. It does the same thing. Sorry about that. Anyway, this concept of all of these signals connected together, you see it, we've seen two of these diagrams, and there's a term for this. We call it a signal graph. The signals are the emissions from the observables, and the graph is how they're all tied together. This is how we architect programs using observables. Our programs become a series of reactive data streams, starting with the primary signals, which are derived from user inputs, and extending all the way to all the different derivations we can make based on those. And taken together, they form a graph. So where I work, we actually program with observables a fair amount. And when we do, and we work on a production application, we actually maintain a graph of all of our signals in our program. This is an example from an actual production application that I've worked on. Now, if you do this in production, there's some concerns that obviously come up. You might be wondering, how do I test this? How do I test my signals? How do you make sure that my graph doesn't have cycles of signals? Because that presents a whole bunch of problems. Or make sure that I'm not depending on signals that aren't there. RxJS, as much as I love it, has a couple idiosyncrasies. Google like hot and cold observables if you want to go down that rabbit hole. And it would be nice to not have to deal with those. One thing that happens in a production application is the graph gets big. And we have this sort of ongoing debate where I work, which is like, do we maintain one giant graph or multiple little graphs? And if you decide to break it up into little graphs, how do you connect those? Finally, maintaining these diagrams is work, and we're like an agile consultancy. We're supposed to value working software over documentation. So, that's a bummer. So basically, I recently was thinking, and I was like, what if we take all these best practices that we've developed in conversations over a couple years of working with observables and encode them into a library so that other people could skip these hurdles? So today, I just want to talk briefly about a library that I've published called Signal. Signal is a library for doing state management in front-end JavaScript applications using signal graphs. So let's take a look at this in the context of our login example. You start in Signal by defining your graph. I'm not going to go into the really low-level details of this DSL, just mostly for time. But basically, it's listing all the observables that make up the graph and how they connect to each other. Primary signals are the inputs, and derived signals are the things that you can come up with from them. Oops. In terms of actually defining the operations that make up your signals, instead of just defining them directly, you define them as factory functions that go from the input signals to the output. Now, the nice thing about this is they're super easy to test. You can just substitute in here sort of like fake signals for the real ones. If you want to hydrate your graph with an initial state, which is a really common problem, Signal provides this function called initialize with, where you can set the initial values of all of your signals. Finally, you just call build. And build essentially takes all that specification that you've given and builds a signal graph. Does nice things for you, like doing topological sort and getting all your dependencies in order. And it will detect cycles or missing signals. So that's really cool. And then one last super cool thing you can do is you can connect two graphs together. Let's say I have my first graph was a graph of all of the things that happen in authentication. And one of the last signals it emits is the status of whether you're logged in. Now let's say you have a separate graph for fetching the sort of protected resources in the application, and you want to connect, and it is going to need to start from the status of authentication. And you want to connect these two. Well, you can just use this connect function, which connects the two graphs together, and you specify which signals are going to be tied together, and then essentially they will emit simultaneously. Oops. Wait, what did I do? Oops, sorry. Right. Oh, right. One other thing about this is that you might be looking at this sort of like DI scheme over here, and you're like, that's like kind of old-fashioned. You're using strings. It looks like Angular 1. Well, if you happen to be using TypeScript, because I love TypeScript, there's a whole other talk about how much I love TypeScript, then you're going to get some amazing type bindings in here, so you can't type in anything wrong. You don't have to use TypeScript, but it makes the experience of using Signal super awesome. So this library is available now. I'm not crimping on my favorite messaging app's name, and that's why it's under a namespace. And the namespace is RxReact, which I'm going to explain in just a second. The caveat is this is not really production ready yet. I've just been messing around with it. So play around with me, but don't adopt it in your production applications just yet. One thing that I really want to do, which I haven't been able to do yet, is I believe you could actually auto-generate those diagrams I showed you earlier. You could, and I think you could use that to get some really amazing debugging insights about like how signals propagate through your program. The examples I showed you are real. They are interactive. I was interacting with them as I talked to you, but I had to hand create them, and I'm still working on an automatic generation. So that's Signal. But you maybe understand RxJS now as an abstract tool, and you might have an idea of how you're going to use it, but how do you tie it to like your good old-fashioned JavaScript MVC framework that you probably use in your day job? So if you happen to be using Angular, step one is that you're done. RxJS is integrated in Angular, and it was a really good decision, I think, on the part of the developers of Angular. And there's also some really good tooling out there. But I use React at my job. And I'm like, I want to use my React with my reactive programming. And that's kind of where this talk started. Basically, I'm always wanting to use RxJS in my React applications, but I always end up using Redux because I work for a consulting company, and I can't be that person who saddles our client developers with a new tool that doesn't, a newest technology that doesn't have great tooling that they don't necessarily understand. So that's why I've been working on a lot of tooling for RxJS and React. And so this namespace RxReact are the various tools that I built for integrating RxJS with React. Now, I want to be clear, these are not the only tools. There's a lot of really great stuff out there. And this is just one offering, and I encourage you to check out the whole ecosystem. But I'm going to show you, this is the one I'm going to show you, so there you go. So the simplest tool I've made is a tool called Signal Connect. And this is basically, if you're using the Signal library, and you want to connect your Signal graphs to React components, you use this thing called Signal Connect. Oh my God, and I messed up something in here. OK, well, that's OK. So let's go back to our earlier example of the positioned ball, right? And this here is a React component that represents our ball. It's a really simple React component. It takes a single property, which is the position, and it essentially just moves that ball to whatever position you specify. It's using that React animation library to do the sort of smooth moving back and forth. So let's say we've now built a signal graph using Signal. That represents the one that I showed you earlier, where we use the clicks on the left and right button to derive the position of the ball. What we're going to do, and I put the wrong, so I need you to imagine the text that says, with view model reads connect. This is the downside of finishing your slides 10 minutes before. You're going to import a function called connect from Signal Connect. This function works a lot like if you've used React Redux. It works a lot like that. You're going to pass it the signal graph and 2 parameters, or in a simple case, just 1. The first parameter represents the outputs of the signal graph, right? These, and the keys in the object you pass here become props on the component that are auto-updated from outputs on the signal graph. In this case, we are tying the position prop to the position signal in the signal graph. And that's basically it. That will move, that essentially every time the position signal emits, the ball will get a new prop for its position. So that's getting data out of the graph. What about when you want to take user events and connect them back into the graph? In this case, that's what the second parameter is for. In the second parameter, each property, it becomes a function, because you're going to need, in the context of a React component, you're going to need to call a function to essentially send data back out. It becomes a function that when you call, whatever you pass to that function will get emitted on the signal you specify in the signal graph. In this case, we're taking the on-clicked handler for the left button, and we are connecting it to the left-click signal. And so basically, every time a click occurs, the left-click signal will admit that it occurred inside the signal graph. And you can actually pass it data. So if you're doing the sort of login example, you could pass in the username and password. Now, I want to show, I was hoping that that was going to come up a little higher. Oh, well, this is actually a real example of the entire login component, and although you cannot see most of it, that's too bad. It actually is, there's basically like 7 signals you extract out of the graph, and that completely connects up an entire login form component. It's pretty cool. Oh, there we go, yeah. Wait, no, hold on. Oh. Okay, cool, we're at the last part of the talk. I call this the used car sales portion because this is where I show you all the other things I've written very quickly. It's also the part where like my notes get a little thin and you know. So here we go. All right, first of all, let's say you don't really, you're like, I don't want to buy your signal graph. Hannah, you don't buy it, it's free, it's open source. Sorry, that's a little awkward. I'm not hawking anything, but you don't want to use the signal graph library. You just want to connect React to RxJS. Well, actually, the first library that I wrote was a library to do that. It's actually a little more stable. And the syntax is pretty similar. You use this function called withViewModel. You define, here's your box component. You define essentially inputs to the component in a thing that's called a view model. This was originally architected from some programming I did in RxSwift. And in RxSwift, you define these sort of like view models to provide data that back your components. And in this case, each input is an observable that becomes a prop. You import this function from RxReact. And then you just call it, it basically operates the same way. The difference here is you're just manually injecting your observables. Same thing happens for outputs. And this is an example of the complete graph. Cool. All right, what about TypeScript, right? So like, let's say you are super concerned about like the stability and structure in your program. You really care, so you want to introduce static typing. Well, the good news is all these tools are written in TypeScript. I kind of love TypeScript, as I said, and there's really strong typings across the board to help you sort of prevent using these libraries incorrectly or just introducing errors into your program. Let's say you love reducers, because everybody loves a reducer, and you've been using Redux a lot, and you want to back your component with a reducer. Well, I've been working on an experiment of essentially modeling a reducer with signals, and this is a function called withViewModel from reducer, where you pass it an initial state in a reducer, and then you can connect it to your component, and effectively you get this syntax that's very similar to if anyone has used Reason React, in ReasonML, which is Facebook's super new language. I basically modeled the syntax after that. That's RxReact Reducer, and that's all I have for my talk. Thanks very much. The slides are up, and they're a little out of date, but I will be updating them soon.